Our study is balanced. We have 10 people per group, and it's post hoc. So post hoc balanced, therefore we're going to use Tukey's. Chef8 is perfectly okay, but it's not as powerful as Tukey's, and why would you cheat yourself of significance? So we're going to go with Tukey's. So, to run our Tukey's adjustment, so we're running contrast tests, and we're adjusting our p-value through a Tukey's adjustment. The command is pwmean dv over, and then in brackets our IV, mcompare Tukey, so this is telling Stata this is how to compare. This is the adjustment I want you to make in my comparisons. And we need to ask for the effects or we'll get nothing. And now what it's telling me is it's taking level 2, so this is the criticism feedback versus level 1, the praise feedback. No feedback to praise, no feedback to criticism. And what I see is criticism feedback to praise gives me a contrast value of 2.5. This simply means that people in the criticism group on average made 2.5 misses more than those in the praise group. It has a standard error of 0.57. This produces a t-statistic of 4.41 and a p-value that is extremely significant. I can see the confidence intervals on the contrast. Now the p-value here is not the same p-value as if I did the t-test like we did before, because you'll remember that no comparison when we did these, if we did this as a t-test, you'll get different p-values to what we're getting here. And the reason for this is the p-value, that the t-statistic that Tukey's is comparing 4.41 to is not the same as if we ran it as a normal t-test. It's a Tukey's value, it's different, it's adjusted, and that produces a different p-value. So here we can see 2 versus 1, that's a significant difference. So because this is positive, this I can then conclude that if you are receiving the praise feedback, you are going to make significantly fewer misses than if you're in the criticism feedback group. Now if I look at the no feedback to praise, I have a contrast value of 1.4. So those who received no feedback on average made 1.4 more misses than those in the praise feedback. It's a smaller t-statistic because it's a smaller contrast value. The p is marginal, it's close enough that we call that significant. But you can see that the lower bound of the confidence interval just drops below 0. Hence we're getting a ever so slightly non-significant p-value, but it's close enough that we'll call it significant. And then if we can compare no feedback to the criticism group, we see it's -1. So what that means is people in the criticism group, people in group 2, actually had more misses than those in the no feedback group. This produces a t of -1.94 and it's non-significant. So receiving no feedback is no different to receiving criticism in terms of the number of misses you're going to make. Now, just as a comparison, let's run the Bonferroni and Chef8 adjustments as well. So now we're using the one-way syntax, and we're just going to add in the subcommands Bonferroni and Chef8. So this is our ANOVA up here. And then the Bonferroni and Chef8 are down the bottom. Here we see Bonferroni, and then we see the Chef8 adjusted comparisons. And so what we see is, in each of these, we can see the contrast values, 2.5, 1.4, -1. These are the same as what we got up here, 2.5, 1.4, -1. But we get different p-values. The difference between praise and criticism under Bonferroni is 0. Under Chef8 is 0.001. Under Tukey's, it was also basically 0. If I look at praise versus no feedback, the p-value under Bonferroni would have been 0.06, and under Chef8, 0.064. But it's 0.051, it's marginal under Tukey's. So here we'd say that there was no difference between receiving no feedback and receiving praise feedback. But under Tukey's, we would say that actually there's marginal evidence that there might be a difference. And this is quite nice because it shows Tukey's produces the smallest p-value, it's 0.051, followed by Bonferroni, 0.06, followed by Scheffé, 0.064. And so this is what I was talking about power. The same test produces different p-values. And then if we look at our last comparison, so this is criticism to no feedback, we get an interesting effect actually. We get Bonferroni with 0.189, Scheffé with 0.172. So we actually see an exception to the rule about power here. But Tukey's is still the lowest. So it is worth knowing that power, the rule, is a rule of thumb. As almost all rules in statistics are, they are rules of thumb. They do not always hold. Okay. So I guess the only other thing to really talk about, we've already spoken about conclusions. The only other real important thing to take away from all of this is we ran all three different approaches to contrast testing. In the real world, that's frowned upon. We call that p-hacking because then you would just choose the test that produces the most favorable p-values. What you should actually be doing is using the logic that we used before, such as, okay, do I have a post hoc or a plan design? Is it balanced or unbalanced? And for us, we said it's post hoc and balanced, therefore Tukey's is the most appropriate. Using a set of logic like this, you then pick the single analysis and run with that. You don't run all of them like we just did.